Video? Okay. Oh, you are in this group. You are not in the screen. Yeah, that's perfect. Coming, you only have half page. Oh, that's good. Go ahead.
Hi, I'm Habib.
I'm Pedro.
I'm Ian.
I'm Fawaz.
I'm Naif.
And we're presenting fully assembled lift jack. Alright, so just to show you what our part will do, let's play the video.
Yeah. So I just.
Let's see. That's the mechanism. We're going to go through the details. It's going to be heavy objects. That's the water bottle. Go down. Okay. So the objectives, when we were thinking about designing this or finding a mechanism to design, we wanted something that is only possible via additive manufacturing. So the part we have right now doesn't need assembly. It's only designed and printed in one part. Only the little knob inside is designed and assembled separately. So this was the main objective, that we do something that is unique for 3D printing. Yeah. You can see, this isn't like a traditional type of lift jack, like inspired by this. And if you go to the next style in the design, you can show you details of so this is like the SolidWorks model from different. You can see in the original part we have these the gaps between the printing lanes, so we can have it, make it movable. And the next part we have the cross section. You see, it's a cross section. All the screws and everything are assembled together. You can see this part, also these hinges here. They're all same part, same. Yeah. Yeah. You want to
So basically, I mean, like you already said, we made it printed in one piece, except for the turn handle. Took about 16 hours to print. We used the LetSpot Mini 3D printer. Our print speed was like 50 millimeters per second, and then our fill density was 60%.
And it took 16 hours to print. Yeah.
Okay, so we use PLA because it's better for more complex parts, and it melts at a lower temperature, so it was able to be used better.
So you can see this is exactly after it's finished printing. It's only one part. So the only thing is after the first time we have to put a little bit pressure to some parts are touching, and then so after that it's like smoothly go up and down. Yeah. You can see all this is screws and everything. The threads of the screws are nicely printed. And also this part didn't require any support material. Yeah.
Okay, so in conclusion, we were able to reach our goal by printing a part that is fully assembled by itself without using any support. We also reached our goal by making it lift a little heavy object. We haven't tried heavier than a water bottle, but I'm sure it can hold more than that.
Yeah.
I guess that's it.
Okay, so we learned a few lessons from this lab, like better ways to design a part, reduce the amount of material used in the part, build a part without any support, design a movable and self-assembled mechanism, understand the tolerance associated with the FDM manufacturing, specific ways to design a part suitable for 3D printing.
What gap size did you use on the movable portion?
1 millimeter.
1 millimeter?
Yeah.
All right.
Actually, it depends what printer you use and resolution of your printer.
Right.
So we use the highest possible quality that group6 could offer, and to use the higher quality profile that we have there. So it's kind of, actually we printed once, it's after a few layers, I saw it's not good. And it was like sticking, the lines were so close together, and then we have to start with like, after I stopped it and start again, and then it was good. Yeah.
Any more questions? Yeah, I do really like the idea that they print all components together, so it's just a one-time printing. So that's a good idea, and you can see the quality is pretty good. So,
Oh yeah, the good thing is like in traditional manufacturing, you have to have like someone to assemble it, man hour. Here, you just the machine do it for you.
yeah, and okay. Any more questions? So if no, then the last one, right? Thank you. Thank you. Group 7.